Okay, we studied last class the logarithmic function, que is the inverse function for the exponential. And you don't put any restrictions in the base. The base is, you know, arbitrary number. No arbitrary, no, it's positive. No 1, no 0. However, in our calculator, we have a standard, que es the logaritmo que everyone working in the real life. So we have two kinds. The first one is called common logarithm. And what is the idea behind common? ¿Qué es the base 10? This is especially using in science, chemistry, physics, because it's more intuitive to understand this. Entonces, the symbolic way, when you know you write in any logarithmic function, you put the word log, you put the base case 10 in that case of something, no? But when the base is 10, default, this number is missing. So everyone in the world understands that you write the word log without a specification of the base is because we are talking about logarithm base 10. Okay. Some problem. Can you see, I write log. Say, Professor, what's the base? No, you need to know that the base automatic is 10. Okay, now we have another. This is using in calculus because have a specific property that is most convenient in calculus. It's called natural logarithm. And the base is one irrational number, que es E. E is approximately, right now you put in a calculator to see, 2.71, A2, A1, A, and infinity decimal place. And the symbolic way to write that, you put logarithmic of E base of X. The symbolic way that everyone knows in the world is ln. You never see this. No, you never see that. Actually, you see log without specification of the base, and lm, and to the default, you know, is E, the base. And E is irrational number, right? Let me use the calculator to explain this idea. Look. Everyone follow me in your own calculator. Let me try. Okay. Okay, there you go. This is my calculator. Okay, of course, it's a calculator online. Okay. There you go. Do you see a calculator? Do you see?
Yes.
Okay, let me clear everything. In my own calculator, no, not my own, the online calculator. I have two calculators on my desk right now. You can find here, look at that E. Is 2.78. This is the base of the natural logarithm. And the natural logarithm is ln. Look, ln of, to say you open the parenthesis, you put, for example, ln E. In this case, 1, because they are perfect coincidence between the base case E and the number inside the argument case E, no? Suppose que I erase this, you put E square. E square. Esto. Also, okay, suppose 3, is 3. Okay, this is natural. And common, here in the functions, log of 10, is 1, log of 100 is 2, log of 1000 is 3, and so on. LOG, remember in the last class, 0.1, 0.1, and -1. And you see that, for example, if you put logarithm of 0, it's undefined, because logarithm is defined only for the positive value and not 0. And negative number, suppose stupid negative number, -3, undefined also. So logarithm is defined only for the positive. Domain of the logarithm function is the positive number or real positive number except 0, 0 no. Okay. Do you see very well? Any question? I promise you we come back to the calculator in your mode. Okay, let me try to again share the whiteboard. For the moment, it's okay, stop. I promise you we come back to the calculator again. Now let me study in detail 8 important properties of logarithmic. Important. Actually, we have 8 properties that help us to manipulate the equation, to make easy everything. Number one, is super important, is logarithm of any base of 1 is equal to 0. Okay, so you see, for example, common logarithm 1 is 0. Natural logarithm 1 is 0. Regardless of the base. Any base is 0. Okay? And of course, another non-standard base is 0. So for any base. The second property is extremely important. Logarithm of the any base, and they are perfect coincidence. The number inside the argument and the base, the answer is 1. Example, log of 10 is 1. ln of e is 1. Log 2 of 2 is 1. And so on. Log of 5 said when they are perfect coincidences between the number inside the argument and the base, the answer is 1. Good. Now, the third property and the fourth property, 3 and 4, is, the same idea, but in opposite direction. Look, suppose que, you know very well que logarithmic and exponential are inverse functions. So you form the decompositions. It's not new for you. You have a function, not necessarily logarithmic, any arbitrary function, and you have is inversed. As you form a composition, so one inside another, the answer is identity. Identity function. This is not new for you. In opposite direction, in this direction. Doesn't matter the order, the answer is the same. Don't always happen that situation, but in this case it's happened. So suppose que f and f inverse is exponential and logarithmic. So you composite it like that. Suppose logarithm base 8 of exponential. Okay, this is exponential, look, and this is logarithmic. So in this case, exponential is the innermost function, and logarithm is the outermost. The answer is x, because does each other. Does. Likewise, exponential of the logarithm of a of x, and this is the exponent, and the exponential is always x. Okay? Everyone follow me? Everyone understand very well? Okay, now we have the super important 5, 6, and 7 property. 5, 6, property. Okay, we're using every day from today. Suppose logarithm of any base of the two expression or number, okay, I want to call m times m. Multiplication. Magically happen. The logarithm convert multiplication to addition. And make it sense. Because remember, the logarithm behave like exponent. And you know when you multiply something with the same base, of course, you add the exponent. So in the word of the logarithm is working similar to the exponent. So multiplication is converted to addition. And this is important in both directions. We are using in this direction or we are using in this direction. When you are using in that direction, it's expand. That we have one single logarithm and you expand in several. And another direction is condensing. Condensing. So we have, I don't know, 8 logarithm and you magically you condensing in only one. Okay, this is super useful. And the equation that you have 1, 2, 3, 4 logarithm, you condense in only one and make easy your problem. Likewise, when it's division, it's subtraction by the same reason. It's logarithm base a of m minus logarithm base a of m. That's super easy because any expression in the top is positive and any expression in the bottom is negative. Let's see example to expand and condensing a more complicated example. This is just the formula. And 7 is similar. It's logarithm base a of m. And we have one exponent, is r. Very, very important, this property. We're using every day that property. Number 7. The exponent go to the front as a factor. So it's r times logarithm base a of m. Okay. Okay, this is a super important property because magically, suppose you have this equation, 2 to the x equal 4. Okay, you can solving using the traditional way. You put this in the common base, get to the second power, and we have to exponential. And you determine x is 2. Okay, this is super easy. This is elementary, you know. But this is the principle. Now, another approach is, look, let me show you. You have this equation again, and you apply logarithm on both sides. ln 2 to the x is equal ln 4. And magically, this exponent go to the front as a factor. And magically, this exponential equation that we have at the beginning is converting now linear equation. Exactly the linear equation that you solve in intermediate algebra. And you divide both sides by ln 2. And x is equal ln 4 divided by ln 2. Well, professor, what is the reason que you select ln? Well, you select any logarithm. I select log or I select ln, right? Now, you put in the calculator if you want this, or no necessary because it's elementary, no? Okay, logarithm of 4, I know 4 is 2 plus 2, no? Or 2 times 2, is 2 plus 2. Entonces you consider que ln of 2 to the second power, no? Divided by ln of 2. And one more time happen, So these two go to the front as a factor. And cancel out that part. And the answer is 8. It's 2. And you see, well, professor, this look like complicated. No. Well, yes. Entonces, my recommendation is the exponential equation that we can solve it. If we can solve it in this approach, so manipulate both sides and expressing the common base is better. However, there are another case impossible. Remember in the last class I set this equation, and this equation is impossible doing by traditional way, so we need to use it that way. So you apply logarithm on both sides, magically happen that the exponential equation is converting now to linear equation, and you solve the linear equation. Okay, now the last property, okay, in my opinion, is the most important, number 8. It's important to receive a special name. It's change of base formula. Change of base formula. Let me try to understand the change of base formula. The formula says logarithm of the any base of the one number that I want to call x is equal division to thing logarithm of another base b of x divided by logarithm of the same base bb of a. Okay, because what is the application of this, professor? Okay, suppose one application of this. Suppose that I need to compute logarithm base 2 of a. Okay, one possibility is one possibility is you have no idea, you convert to exponential, the base is 2, the exponent is x, the answer is 8, but I know that a is 2 to the third power, therefore we have 2 exponential, the same base, therefore x equals 3, end the story. Okay, this is the classical approach by hand. However, we can use a calculator. Some students prefer, because this is easy. This is straightforward, but not always. It's easy. Sometimes it's complicated. You say, no. This logarithm that the professor put in the test, that the base is 2, is non-standard. However, I know that in my calculator, I have a standard. So I put log, suppose I make a decision of 8, is that part, divided by log of 2, is the base. Okay, let me try to understand that part and that part. Okay, similar. And in the chain of base formula, we have 2 bases. The original base A, in our example, is 2. X is A, okay. In the right hand side, we have another base, que es B. In this example, is 10, because I select the common logarithm. And this 8 is x again, and this A is 2. And you put this in the calculator, and I suppose that you get the same answer, right? Like this. Okay, let me show you. Bueno, before that, well, yo sé, professor, si I select another standard que se lee, you get the same answer? Of course, you get the same answer. Okay, the answer that we expect is 3. See, we are doing well, no? Let me try in the calculator, in my online calculator. I encourage you to try to do in your own calculator right now with me and verification. Okay. Boom. Okay, is functions. Select log, for example, of 8. Outside the parenthesis, divided by log again. 2. Boom. Do you see the 3?
Yes.
You did your own calculator?
Yes.
Okay. Now, well, by curiosity, I want to do using LM functions, LM of 8 divided by outside the parenthesis guy divided by LM of 2. Oh, saying us it doesn't matter what logarithm you select. And the answer is completely independent of the base que you select, si es 10 or si. Okay, one more example, and you help me. Okay, we are using the chain of base formula. Okay, switching to the whiteboard now. Okay, the application of the chain of base formula. Compute logarithm base 3. Oh, let me see. Base 4 of 81. Base 4 of 81. No. Base 3. Sorry. Base 3 of 81. Entonces we can do it by hand or calculator. What do you prefer? Calculator or hand?
Hand to see how it works.
Hand to see it's working. Because sometimes doesn't work. Because in this case it's super easy, but in another case it's not easy. And you convert to exponential. This is 3 to the x equal 81. You know that 81 is 3 to the 4th power, no? Because 81 is 9 times 9, and 9 is 3. Actually, 81 is formed by the multiplication 4, 3. Therefore, the answer is 4. Boom. Same exponential, same base, the exponent is the same. However, if you're using the famous, you put log 81 divided by log of 3. And I don't care what logarithm you select. You have two possibilities of the standard, natural or common. You select it. Some people, no, I don't like natural. I like common. Okay, no problem. Put in the calculator and end the story. Let me try. Do you see? The calculator, you see or no?
Yes.
Got it? She's common, no? We select common. 81. Divided by log of 3. Boom, 4. Okay? See, I select was another. It's okay. Any question? So let's move on now to the solutions of the complicated exponential equation. Que this complicated is mandatory using calculator. Okay. Okay. I want to erase everything. Well, the answer of this was 4, no? Do you follow me, guy? ¿Es easy or no? Answer me. ¿Es easy or no?
Yeah, we got it.
Okay. So now we dedicate the rest of the time solving a complicated exponential equation. It's an equation that we cannot solve using the traditional way. Remember, you manipulate 2x equal 3, for example. This is a classical example. Remember, it's important that you see the difference between this and this. 2 to the x equal 4. Oh, in this case, it's easy because I know que 4 is 2 to the second, exponential, same base, x equal 2. End the story. In this case, no. Impossible to do this. Therefore, you apply logarithm of both sides. What kind? I recommend a standard. Because definitely, we finished that problem using the calculator. So you apply log, for example. Some people, when they write logarithm, write like that, log of 3. This is correct. This is correct. But I like you enclose in the parentheses because this is like a function notation. No? Let's see, you write like that, f3. Nobody understands this very well. But it's okay. Specifically, the majority of the student don't put the parentheses, but it's understandable. Okay, now you apply in this crucial moment the property number 7 can allow me this exponent go to the front as a factor. So we have x times log of 2 without x, because x fly outside, equal log of 3. Finally, so solve for x divided by log of 2 both sides, similar to the linear equation. Wow. Well, how you solve 2x equal 3? You divide by 2. That's it. Of course, no es 2 or 3. It's logarithm of 2 or logarithm of 3, but it's a numbers. And this number we can compute it using the calculator, of course. Okay. Divide both sides by this. And definitely x is equal log of 3 divided by log of 2. Okay, so now this is the exact answer. But in the real life, we don't need the exact answer. We need the approximate answer. And the approximate answer, you put the R symbol in the case approximate, and you put it in a calculator. Normally, the logarithm of the number que es no múltiplo or power of the base is irrational number. So we have infinite decimal place. Now in the test, I specify how many decimal place you round off. Normally, see no specification, you select 4 decimal place. So let's move into the calculator. In the calculator, you have. I appreciate so much that you try to do by yourself, guys. Now, on your own calculator, you need to be familiar with your own calculator, specifically that part of the logarithmic. Okay. Okay, clear all. Here I put in my calculator log log of 3. Okay, outside the parenthesis, division, log again of 2. Boom, I copy that. Suppose que I need 4 decimal place. Entonces 58,496 actually is 5850 because you want to round off to the 4 decimal place 1, 2, 3, 4. You analyze the digit after the 4 place, in this case 6. So si es greater than 5 or equal to 5, you adding 1. Entonces the answer is 1.5850, no? According to this approximation. The answer of this problem, our problem is, okay, is 1.5850. Final answer. Everyone follow me? Everyone understand very well this? Okay, this is, so remember, we have two kinds of exponential. The exponential okay, we are solving using common base. Exponential que we are for solving using logarithmic. Okay, let's move on to more complicated example. Any questions so far? Example 2 now. No?
All clear.
All clear. Okay. Okay, example 2. Example 2 is 5 parentheses 2 to the 3x equal 8. Okay. Okay, what should I do? Well, in my opinion, you isolate the exponential part. So you try. Now this 5 is a noise. You solve the exponential part. So say you divide by 5 both sides. Good. And you have so far 2 raised to the 3x is equal to 8 over 5. It's obvious that we cannot solving by the approach that you put the equal base. So definitely you apply logarithmic. Okay, so you apply logarithm. I make a decision to apply the comma. I don't know why. There are no specific reason. You know, the answer doesn't matter what logarithm you apply. I promise in the next example you apply natural. And one more time you apply the property number 7. Okay, fantastic. And the property number 7 allow me this exponent go fly outside like a factor. So I write 3x time, of course, logarithm of 2 is equal to logarithm of 8 over 5. Okay, therefore, logarithm no. My goal is solve for x. Now you divide both sides. You divide both sides by 3 logarithm of 2. 3 logarithm of 2. Now x alone is logarithm of 8 over 5 divided by 3 times logarithm of 2. And the rest, well, this is the exact answer, but whenever I need the exact answer, I need the decimal approximation using 4 decimal place. Maybe, no? Entonces now I'm using the calculator. This is a moment to use a calculator. Be careful with the calculator. Be careful, be careful, be careful. Be careful because in the calculator I put logarithm a over 5 inside the parentheses. And when you divide by two things. So I highly recommend using parentheses. Okay, to enclose everything at the bottom. Let me show you. Okay, do you see the calculator? Yes. Entonces, I put in the calculator log what? A over 5. A division 5 inside the parentheses. And outside the parentheses, you put division again. And you open the parentheses, and inside the parentheses you have 3 times another logarithm que es logarithm of 2. Boom! I copy the answer. The answer is 0.2260 and 23 something, no, 23984. Yeah, I need 4 decimal place, 1, 2, 3, 4, and then the next digit after the decimal place 2 is less than 5, so you trunk it like that. And the answer is 0.2260. End story. Everyone get the same answer like me? You get the same answer like me?
I got the answer without having to put it in the parentheses, like the 3 log. I only had to do like 3 log parentheses.
Was not necessary to put the parentheses, you say?
Yeah, like I got the same answer.
Okay. What is the problem of this? Let me explain in detail. So I copy the answer, get 0.2260, no? This is my final answer. The majority of calculator, suppose you divide, for example, 6 divided by 2 times 3. In the language of the calculator, in the paper, no. In the paper, you know the order of operation. You multiply this first, and the answer is 1, no? But in the calculator, you put 6 division, 2 times 3. So the calculator operates from left to right, and let's do this operation first. 6 divided by 2 is 3, and 3 times 3 is 9, and it's the wrong answer, right? However, if you enclose in the parentheses, the calculator understands very well that you are doing this first. So say 6 divided by 6. Make sense? Make sense?
Yes.
So I highly recommend when you have 2 guys, 3 guys, in the bottom, you enclose the parentheses, right? Any question? Was easy that problem or no? Was easy. Bueno, entonces I want to complicate your life a little bit. Okay, can erase? Example 3. Okay, example 3 now. In example 3, we have this equation. 0.3 raised to the 1 plus x is equal 1.7 raised to the 2x minus 1. Well, this is a classical example that we cannot solving, manipulate both sides because it's impossible to express it using common base. But definitely, we need to use a logarithmic. What kind? Standard. What kind of standard? The standard you want. I want in this example. Why no? No discrimination, natural. Okay, nice, I like it. One more time, you apply the property number 7. Okay, fantastic. Allow me this exponent go to the front, and this exponent go to the front. But be careful because this is binomial. It's a binomial, you put the parenthesis 1 plus x times ln of 0.3 is equal to x minus 1 times ln 1.7. And don't worry for ln 0.3 and ln 0.7, it's just a number and you put in the calculator, of course. The rest is algebra. This is linear equation now. Look, this is exponential equation. And this is no exponential equation anymore. This is linear. This is the beauty of the mathematics. Apply this operator or that function, magically we convert exponential equation to linear equation. And the rest is piece okay, similar to the intermediate algebra. You apply this distributive property here. 1 times ln is ln 0.3 plus x times ln 0.3. Pam, pam. Likewise, in the right hand side is 2x times ln 1.7 minus ln 1.7. Okay, my goal is, of course, x. So I try to group in the term that contain x to the one side. Well, I recommend right hand side, so this stay here. And this I move because I want to group in the guy can do not contain x in the right hand side. Doesn't matter what side, but okay, I need to make decision. No? This stay here, this is minus x ln 0.3. Everyone follow me in this manipulation? Okay. Now I copy ln 0.3 plus ln 1.7 and you factor x, que es a common factor. And we have ln 2 times ln 1.7 minus ln 0.3. Okay. Finally, you divide both sides by this number because my goal is isolate x to 1.7 minus ln 0.3. Okay, now so far it looks like horrible, but I want to simplification this. ln 0.3 plus ln 1.7 divided by 2 times ln 1.7 minus ln 0.3. And this is x value. And you put like that in the calculator? No. No, because one more time we're using the property. For example, what property are you using? Well, in the top, I'm using the famous property 5. And the famous property 5 convert two logarithms and addition like a multiplication. So now we have, you condense this logarithm and this logarithm and only one. And inside the argument, I put in my calculator, I put 0.3 times 1.7. And the answer is 0.51. Where I come from 0.51 was the multiplication, that number times that number. Yeah, I condensed it, these two logarithms in only one. This is a super fantastic way. And the bottom, well, in the bottom we're using the combination of the property number 6. And remember the difference in 5 and 6 is subtraction, because I see minus here, right? And the property 7, why not? The property 7 because this factor we're doing backward in opposite direction. I put like exponent. So you condense in this logarithm of 1.7 squared divided by 0.3. Let me try. Of course, I put in the calculator 1.7 squared divided by 0.3. The answer is 9. Okay, this is equivalent. This stays the same. But this no. I compute in the calculator and the answer is 9.6. 9.63 repeated. Now ready to put in the calculator this. Okay, let's do it. Let's do it. Okay. If you want, not necessarily compute this, you put in the calculator this original version, this one. Okay, and the calculator, solving everything. Okay, let's do it. Well, okay. Do you see calculator, right?
Yes.
You put in the calculator ln 0.51 outside the parentheses division, another ln of the 1.7 square divided by 0.3. Boom. And the answer is negative. I want to analyze why it's negative, professor. It's negative something. Negative 4 decimal place, 29.725. So actually it's negative 0.2973, no? Using 3 decimal place. Don't worry too much because the approximation for the any calculator is different. But it's okay, it's close. What is the reason that the answer is negative? Makes sense or no? Or is contradiction or something? Okay, remember the base of the logarithm that we are working in that problem is E. E is 2.7 something. And this is greater than 1. However, the number that you put inside the argument is 0.51, que es less than 1. That is the reason that the logarithm at the top is negative. Remember, when you have contradiction in between the base and the argument, contradiction means that the base is 2.7 and the number in the argument is less than 1, 0.51. However, in the bottom, no. In the bottom is 1.7 squared divided by 0.3. I computed before is 9 point something, and 9 is greater than 1. That's the top. So responsibility to be negative. This problem is the top part, que es negative, and the bottom positive. And negative divided by positive is negative. Okay, the answer is negative. Negative. Okay, come back. Whiteboard, come back. The answer is negative 0.2973. Makes sense? I put in a calculator like that. No this. I using this expression to avoid approximation, 3 repeated, 3. No. Any question, right? Clear? Let's see now a couple of the complicated exponential equation. Okay, have another approach. No, the same, but another detail. So example 4 and example 5 is complicated. Let me try. Example 4. Example 4 say 4 to the x power minus 10 times 4 to the minus x equal 3. Wow, what the hell is that? I want to avoid negative exponent, no? It's not good. So if you, for example, multiply by 4 to the x, my whole equation, entire equation multiply, we have 4 to the x times 4 to the x minus 10 times 4 to the minus x times 4 to the x equal 3 times 4 to the x. Okay, the reason I did that is because somehow I want to eliminate negative exponent, no? This is 4, and this is x plus x to x. Because of multiplication, you know, multiplication, when you have the same base, adding the exponent, x plus x to x, minus 10, and this is negative x and positive x1, x0. So 4 to the minus x times 4 to the positive x is 4 to the 0, and 4 to the 0 is 1, and 1 is invisible. It's just 10, equal 3 times 4 to the x. Wow, in this moment, I can see that this equation look like equation quadratic in form, similar to the equation that we studied in the chapter 1. Why, professor, why? Because, look, suppose this is 4 to the x squared, right? When you have different multiplication, or you write like that, like a different level, minus 3 times 4 to the x minus 10 equal to 0. Wow. If, for example, you are doing u substitution equal 4 to the x, you have here u squared minus 3u minus 10. You see the transformation there? So you realize that this equation is quadratic in form. How do you know that? What is the clue that give me that information? Well, we have something expression here, 4 to the x, and we have duplicate exponent. It's a square, and you using u substitution, you convert this ugly equation in one nice quadratic equation, no? And you solve the quadratic equation by quadratic formula or by factorization. In this case, factorization is good because the combination is 5 and 2. Because 5 times 2 is 10, and 5 minus 2 is 3. What sign? Well, minus 5 and plus 2. So see, we have u minus 5 equals 0, u is 5, and u plus 2 equals 0, u is minus 2. This is the answer? No, of course no, because this is the u value. Remember the idea behind quadratic in front. You are doing substitution, you make complicated to easy equation, you solving, but the solution I have in my hand so far is u value, no x value, is the value I need. So actually, we convert this equation in two exponential equation using phi and negative 2. 4 to the x is equal 5. And likewise, 4 to the x equal minus 2. Right? Oh, it's easy. This is the traditional exponential equation that we solving using logarithm. Okay, what kind? Bueno, natural, I suppose. Natural 4 to the x equal natural of 5. Again, we apply the property number 7 que allow me to put the exponent to the front. Finally, divided by ln of 4, both sides, x is equal ln of 5 divided by ln of 4. I put in the calculator. I don't want to repeat the calculator, you know. You let me know si I am doing well or not. The answer is 1.1609. This is my first solution. And my second solution, wow, my second solution is weird because I saw something weird here. Exponential base 4 is equal to negative 2. This is impossible. Why is impossible? Because I know that the exponential function graph always look like that. 4 to the x. And negative 2 is a horizontal line here. Never intersecting. No solution. Okay, no solution. Wait, okay. Professor, okay, I understand that, but I don't see this. Okay. Okay, you are doing exactly the same procedure. You apply logarithm on both sides. You now apply the property number 7, you put this to the front. And this is the problem. I see contradiction because logarithm of number negative is undefined. Again, no solution. So that part do not put any solution in the problem. And the only solution that we have is this. Super clear? Or extremely confusing?
Professor, you didn't round the 9. I think it's supposed to be 1.1610.
All right, let me see. Because the next digit is greater than 5.
Yeah, after 9 it's 6.
Let me check it. Let's check it with the calculator. Maybe you are right. Okay, it's logarithm of 5 divided by logarithm of 4, right? Ln of 5 divided by ln of 4. It's 1.160. Yes, you are right. You are right. You are right. Actually, it's 1.1609. Entonces, after the 9 is 6. Es obvio que you round is 10. Entonces, 1.1610. Yes, super. Thank you. Okay, the answer is no, 9 is 10. Good. Any other question? Okay, let's see one similar. Let me see another similar problem. This is, this is more complicated because you need to use another concept of the algebra. You know, no? A quadrant from, etc. And finally, we ending in the exponential equation using logarithmic. Let me try. Let me try another example, but it's very, very similar to this. A little bit more complicated. Suppose example, what is the number of this example? 5, no? Example 5. Example 5. This is example 5. Okay, example 5 say. Nine raised to the x equals 6 raised to the x plus 4 raised to the x. Wow, what the hell is that? Well, I know that 9 is 3 to the second. I know that 6 is 3 times 2. I know that 4 is 2 to the second. So then you replace, and let's see what happens. I don't know. So it's 3 to the second raised to the x is equal 2 times 3 raised to the x plus 2 to the second raised to the x. Actually, this is 3 to x. This is 2x times 3 to the x. And this is 2 to the 2x. Do you follow me? Do you follow me?
Yes.
I propose to, this is the smart idea now. You divide the entire equation divided by 2 to the 2x. Well, let's do it. 3 2x divided by 2 to the 2x is equal to 2 to the x times 3 to the x divided by 2 to the 2x plus 2 to the 2x divided by 2 to the 2x. Well, I can see that this guy is 3 over 2 raised to the 2x equal. In this case, it's obvious that we cancel out at least one with this and this, and stay alive 3 over 2 raised to the x plus 1. Do you see the transformation? And one more time, we have a quadratic form equation. How do you recognize a quadratic form? Well, you have one expression, and one exponent is x, for example, and this is twice, it's quadratic form. So what is u? What is the u definition? The u definition is 3 over 2 to the x. So you take the smaller exponent, expression that contains smaller exponent, and this is u squared, and this is u plus 1. Okay, quadratic equation, u squared minus u minus 1 equal to 0. By factorization, it's impossible solving this equation, but by quadratic formula, yes. A is 1, b is -1, and c is -1 again. Minus b plus and minus square root b squared minus 4ac divided by 12. Okay. B is -1 and double negative become positive. Plus and minus square root. 1 squared is -1 squared. Okay, positive 1. Minus 4 times a is 1 and c is -1. Divided by 2 times 1, que is just 2. Inside the radical, we have 1 plus 4. Okay, fine. Actually, it's -1 plus and minus radical 5 over 2. Wow, it's irrational solution. It's irrational. How do you know it's irrational? Because when you have a square root of the prime number, it's irrational. But it doesn't matter. When you apply logarithm, you get irrational solution again. So no problem. So I put in my calculator because we have two solutions. No, one solution is 1 plus radical 5 over 2. Another is 1 minus radical 5 over 2. By curiosity, I put in my calculator, I compute the decimal approximation. The answer is 1.61, and the answer is negative 0.61. Because definitely, I discard this solution because I know that exponential never is equal negative number. So I take the solution positive. This is to check, you know, it's obvious and negative because radical 5 is bigger than 1, no? That my final answer then is 3/2 raised to the x power is equal 1 plus radical 5 over 2. I take this, know this. Now ready to apply logarithm. What kind? Well, I don't know, the logarithm that you want. In my paper, I'm using ln again. Ln of this and ln of this. Again, property number 7 is fantastic. Allow me put the x in the front. Finally, divided by ln 3/2, both sides. X along my solution is ln 1 plus radical 5 over 2 divided by ln 3/2. And the rest is calculated. Checking, guys. I do in my calculator, and the answer is approximately 1.1870. Checking in your own calculator. If you want, I do in my calculator. No? So you have no coincidence with my answer. Okay, using my calculator. Well, I can show you in the calculator. I am back. You get the same answer like me or no? Let's check it, just in case, to make sure. Okay, calculator now. Okay, do you see or no? Do you see calculator or no?
Yes.
Yes.
Let me say something. You see the calculator and you see whiteboard together or no?
No.
No, only the calculator.
Only the calculator, and the rest is black color, no?
Yes.
Because in my computer, no. In my computer, I see the whiteboard and the calculator. Okay, no problem. I need to know that. Okay, now clear. Okay, so my problem is natural logarithm function, natural logarithm. And inside the natural logarithm, we have fraction. To say, I suppose that the best way is you open the parentheses because I want to enclose the top part of the fraction because the binomial 1 plus radical 5 and outside the parentheses you divide by 2 outside the all parentheses you divide again by ln of what? 3/2. 3 divided by 2. 3 divided by 2. Boom. And the answer is 1.18681. Entonces, si you round to the 4 decimal place, 1, 2, 3, and 4. No. Entonces, I did wrong. Es 1, 2, 3, 4. Next digit after is 1. Entonces, es 1.1868. End the story. No 7. 68. You get the same answer like me? Yes or no?
Yes.
Excellent. That's 68. Let me fix it in the whiteboard. Okay. Entonces, 1868. Finals. It's important, guys, if you try to do on your own calculator, because on the test I cannot help you, no? Clear the exponential equation. We solving from the super easy elementary and complicated. I promise. Okay, in the review packet, we go over again at the beginning, no? Any exponential equation. It's important, extremely important. Okay, let's move now to another topic. Okay, similar. It's now logarithmic equations. Oh, this is another kind of equation that's important because in the application, que es the last topic, not today, logarithmic equations. Es equation que contain only logarithmic. Entonces in this case, let me explain something important. You know, the domain of the exponential function is all real number for the exponential. That's the reason que exponential equation is nice. Accept any number, positive or negative. However, in the logarithmic function, no. The logarithmic equation, the domain of the logarithmic function is 0, infinity. So no negative value and no 0. That's defined. So when you're solving, I want to explain how you're solving logarithmic equation. In one moment, you get solutions, and mandatory, you need to verify the solution into the original equation. Because see, any solution is out the domain is completely extraneous solution, no good. So in this case, mandatory checking in logarithmic equation is similar. Do you remember a radical equation that when you solve and you transform it, you get solutions, potential solution, and you plug it into the original to verify. In this case, exactly the same. It's the same thing because it's the same problem of the domain. Okay? Let's do what example? Example 1 of the logarithmic equation. Suppose logarithm base 3. In this case, not necessary standard logarithmic. I put it arbitrary crazy logarithm base 3 of x minus 24 equal 4. Okay, this is my equation. Sorry, this is 3. And this is 4. 24. Okay, so the procedure is always the same. Always the same. You have 1, 2, 3, 4, 5 logarithms, you condense it in only one. So you apply the property number 5. In this case, I know that number 5 because it's plus. You condense this logarithm in only one single, que es the multiplication x times x minus 24. I put the bracket. This bracket indicates the argument for this logarithm. Or parenthesis, doesn't matter. Double parenthesis, but I like bracket, I don't know why. Okay, do you understand? Very important step. Condense. You have 2 logarithms, 3 logarithms, 5 logarithms, you condense in only one logarithm. Okay, now the second step, in my opinion, is the most important step. You convert this logarithm statement to exponential statement. Entonces, I would like in the test you put it wrong and you put conversion to exponential. You understand very well the action we were doing. And remember, how we convert? I asked by myself, what's the base? Oh, the base is 3. Look here, that number is the base. And you put now a big 3 in the exponential statement. What is the exponent? I raised 3. Oh, it's the answer for the logarithmic is 4. That 4 represents the exponent. It's equal to the rest of the equation, that is x minus 24. Do you understand very well this transformation, how we convert logarithmic statement to exponential statement? No problema. Okay, now easy. 3 to the 4th power is 3 times 3 times 3 times 3 is 81. So far we have 81 is equal, why not distribute the property here? There are no reason to have that parenthesis, x squared minus 24x. And this looks like a quadratic equation. Okay, let's solve it. It's x squared minus 24x minus 81 equal to 0. I put in standard form and ready to solve it. I don't know if you see the combination of the factorization, and si you don't see, no problema, because we are using the quadratic formula, no? But in this case, some students saw the combination for the factorization. Two numbers can multiply each other. Give me 81, and somehow, when you adding on subtraction, give me 24. Do you see the combination or not? Some students saw the combination.
Professor, sorry, but can you explain again how it's 3 exponent 4?
Yeah. Remember the idea behind, this is important. I appreciate so much your question. You have missed one logarithm statement. You have base, result, and exponent. When you convert to exponential statement, you transform it like that to exponential. You put the base here. Okay, in our example, the base is 3. You see this small 3? I put the big because it's the base. And the exponent here is 4 because I know very, very well that the answer for the logarithm statement is exponent equal the result. This is the thing I am doing. It's clear for you?
Yes, thank you.
Excellent. Now we focus on our step. Last step is super easy for us. Do you understand that I somehow, look at the transformation. The transformation was, I have the original equation. I condense in the logarithm in only one. I transform the logarithm statement to exponential statement. And magically happen, wow, we have quadratic equation. And you solve that quadratic equation. Okay? My question was, do you see the combination by factorization 81 and 24 or no? No? No problema. Let's do it by the traditional quadratic formula. A is 1, B is negative 24, and C is negative 81. Minus B plus and minus square root B squared minus 4AC divided by 2. Okay, entonces 24 double negative become positive. Plus and minus square root negative 24 squared minus 4 multiplication by A que es 1 multiplication by C que es negative 81 divided by 2 times 1 que es just 2. We focus in the expression heavy raining here. But don't worry. I solved that part. Negative 24 squared is 24 squared. Is 576. And double negative become positive. 4 times 81. 324. And together, wow, 900. And square root 900 and 30. So basically 24 plus or minus 30 divided by 2. Separate into pieces. 24 plus 30 divided by 2. And 24 minus 30 divided by 2. This is 54 divided by 2 is 27. This is minus 6 divided by 2 and negative. Wow! Look, by factorization was easy because suppose that some students saw the combination. The combination is 2 parentheses, XX, 27 and 3. 27 is negative and 3 is positive. Negative 27 times 3 is 81, and negative 27 minus 3 is 24 negative. Then we have two solutions, 27 and 3. And this is the answer. No. Why not? Because you need to verify. The checking part is extremely important. That you have two solutions. No. Checking part. Check for 27 and check for negative 3. Well, it's obvious that negative 3 doesn't work. Why? Because when you plug in here negative 3, it's completely undefined. So logarithms do not accept negative number. Okay, not always happen. Well, this is a fact. Logarithm negative number is undefined. But depending on the problem, so no universal you see, no, negative doesn't work. Not dependent, no? You need to plug it in because suppose that you have, for example, I don't know, instead of x, you have another expression more complicated. It's x minus 4 or plus 4. When you plug in negative 3, you have negative 3 plus 4 is 1. Okay, does it work? Maybe. I don't know. So I'm plugging in here, but in this case, obviously yes. But let me check into any second. And we practice a little bit. Logarithm. Logarithm by 3 of 27 plus logarithm by 3 of 27 minus 24 should be equal, I claim that, I'm not sure if it's true, equal 4. Okay, it's doing. Now, subtraction. Logarithm by 3 of 27 plus logarithm by 3 of 3, no? Because 27 minus 24 is 3, equal 4. So I remember something. I remember the property of the logarithm. Logarithm base a of a is 1. Property number 2 that we studied today. It's obvious that this guy is 1. So logarithm base 3 of 27 plus 1 equals 4. Therefore, logarithm base 3 of 27 is 4 minus 1 is 3, no? So you move 1 to the right-hand side subtraction. And this statement is true or not? What do you think? Suppose I do by hand, and after we choose in calculator. Logarithm base 3 of 27. I have no idea. I change to exponential statement. What do you say?
that I think it's true because 3 to
Yeah,
the 3.
yeah. It's exactly the exponent we need. 3 to the third power is 27. 3 to the third power is 27, therefore x equals 3. It's fantastic. This statement is true, and this is the confirmation that the only solution that we have in this logarithmic equation is 27. Boom. End the story. Solution set. Solution set. Solution of this equation is, let me erase that part, is solution set 27. Any question? Do you understand very well or no? Okay, you see, I recap. What is the step that you need to apply for solving logarithmic equation? Number one, condensing several logarithms in only one. Number two, convert logarithm statement to exponential. The rest is algebra. What can I have no idea. But the equation, cross multiply, is algebra, elementary algebra. And extremely important, when you get the solution, plugging it into the original to verify the solution works or doesn't work. Clear? One more example. One more example. One more example. Example 2 of the logarithmic equation. Say, example 2. Suppose logarithm base 2. Wow. Of 3x minus 2. Minus logarithm base 2 of x minus 5 is equal to 4. This is our second example. Okay. So in our second example, we're doing a similar idea. We have two logarithms, we're condensing in only one, but in this case you apply the property number 6, no number 5, because it's minus. This is logarithm base 2 of the 3x minus 2 in the top and x minus 5 in the bottom. Don't forget the parentheses. Equal 4. Everyone follow me this idea?
Yes, yes.
Yeah, minus is division, right? Now you convert to exponential. Just the part is confusing. You convert this statement to exponential. Entonces, who help me? What is the base? What is the base? What is the base? In your opinion, what is the base? What number is the base? What number is the base?
2.
2. And you put 2, big 2, because of the base. What is the exponent? Can you raise 2? 2 to the something. 2 to the something. What is the number here inside this box? You need to know. Yes? What do you say?
4.
4. Very well. Okay, guys. Mnemonic device to remember that. Of course, this small number represents the base in the logarithm statement. And I need to know the answer of fair logarithm statement is exponent, always, right? It's equal to the rest, and the rest is the expression inside the argument, is 3x minus 2 divided by x minus 5. And you compute that. 2 to the 4th power is 2 times 2 times 2 times 2 gets 16. 16 is equal 3x minus 2 over x minus 5. And this is super elementary equation. Cross multiply, you apply cross multiply. Okay, to delete somehow the fraction. And you have 16 times x minus 5. I put the parenthesis, no? Because 16 multiplied whole thing equal 3x minus 2. Time 1 is invisible. Now distribute it. 16x minus 80, no? Yeah, 80. 3x minus 2. In this case, no was quadratic equation, was linear equation. Therefore, we expect one solution, only one. 16x minus 3x is equal minus 2 plus 80. We have 13, and this is 78. Divided by 13 both sides, so will be okay 6. Yeah, I need to check and see 6 work or doesn't work in my problem. Okay, I come back at the beginning, original equation. Yeah, I checking. Check the potential, solution 6. Because I need to compare a logarithm base 2 of 3 times 6 minus 2. You replace x for 6 minus logarithm base 2 of 6 minus 5 should be 4. I claim that. I'm not sure that this statement is true. Let me try. Logarithm base 2, okay, 3 times 6 is 18. 18 minus 2 is 16. Minus logarithm base 2, 6 minus 5, 1. Should be 4. But I remember very, very well the property number 1 that we studied today. Today we studied one property is logarithm of the any base of 1 is equal to 0. Wow, logarithm of 1 is 0 regardless the base. Okay, it's 2, 3, 4. This is 0. This is gone. 0. Because I need to prove somehow the logarithm of base 2 of 16 is 4. Guys, there are no excuse. You can do by hand or you can do by calculator. Using the, let's do it in both ways. Suppose the student can lie by hand. Well, okay, you, for example, you convert this statement to exponential. Why not? And the base is 2, the exponent is 4, and the result is 16. Oh, this is super true. 16 equals 16. End the story. Another possibility is, okay, no, I don't like this, professor. I like calculator. Okay, so you use a standard logarithm. Logarithm of 16 divided by logarithm of 2. Yeah, I put in the calculator and surprise. What's the answer? Okay, let's do it quickly. Do you see the calculator?
Yes.
Okay, and the thing I can verify, no? And the calculator is, let me see, I don't remember. Log 16 divided by log 2. Okay. Okay, it's log. I make a decision to using this standard. 16. Okay, outside the parentheses, division by log again of 2. Boom, the answer is 4. I proved that. Calculator or hand? Well, I ask you, what way you prefer, using the calculator or by hand? What do you prefer, calculator or by hand? Huh?
By hand.
By hand. That depends on the problem. No? Sometimes by hand is easy. This problem is easy, but sometimes no. Okay, the solution. What is the solution of this equation? Solution set is 6. Okay, one more and that's it. We continue next time. I want to erase the board, right? Do you see the whiteboard or no? Do you see the whiteboard?
Yes.
Yes, okay. Example 3. I like this example. Okay, now next time we are doing, let me see, a couple more. 3 examples of the logarithmic equation, and we start the applications. Application of what? Application everything we study. Application in the real life, biology, chemistry, physics, finance, the exponential and logarithmic functions. Suppose logarithm base 14, a noise. Some people make a noise. To avoid the noise, you putting off the microphone. Hey. Oh, who make a noise? Okay, good. Logarithm of, okay, the base of the logarithm is 14. So, and the problems, they put crazy base, 14, 2, 3, or even the standard. In another example, you see standard of x. Okay, in this case, this problem brings me a new situation. Because remember, the first step is condensing the logarithm in only one. But to condense it, we need in the same side. Okay, so we change. Logarithm base 14 of x plus 5, no problema, I copy, plus logarithm base 14 of x equal 1. Okay, now condensing, use the property number 5. It's important, guys, to condensing, to apply the property number 5 or 6 or 7, we need the base is the same. See, the base is different, no. And let's see what need to do when the base is different, but not today. Next class. Now you multiply logarithm base 14 of x times x plus 5 equal 1. And we convert immediately to exponential statement. The base is 14, the exponent is 1, that by the way is invisible. You don't need to write 1. Equal x times x plus 5. Everyone understand very well that part or no? Everyone understand that part, the conversion logarithmic statement to exponential statement? Yes or no?
Yes.
Yes.
The rest is apply distributive property. X squared plus 5x minus 14 because I want to put in standard equal to 0. I apply distributive property, I move 14 to the right, and you interchange because in the equation we can interchange. And you have that. In this case, super easy by factorization. The combination is 7 and 2. 7 times 2 is 14, 7 minus 2 is 5, and the signs are positive and negative. And we have two solutions, x equal minus 7 and x equal positive 2. It's obvious that the solution negative 7 doesn't work because you try, you put in 7 here, negative 7, logarithm of negative number is only 5. So the only checking we should do is in 2. The checking is mandatory. See, I don't see checking in your test, no full credit for you, okay? And logarithm equation, mandatory checking. Check for x equal to. So I copy logarithm base 14 and the original 2 plus 5 should be equal. I claim that 1 minus logarithm base 14 of 2. Well, no, actually this is 7. Well, So let's do a similar idea. Okay, we are doing the solution. No? I move this logarithm to the other side. Plus logarithm base 14 of 2 should be 1. And we condense it again, apply the property of phi. It's multiplication. Logarithm base 14 of 7 times 2 to 14. Wow, fantastic. So you apply the property number 2 that we studied today, the logarithm of the any base, and when inside the argument we have the same number as 1. In this case, the base is 14 and the argument is 14, 14, 14 is 1. True. Therefore, the solution x equal to work. Solution set for this equation is just 2. End story. Do you see? Okay, so we continue next time. Okay, we continue next time. We are doing well today. Okay, guys, have a nice day.